Artificial intelligence. We hear about it everywhere, right? It's in the news, in the movies, and often it feels like this complex, futuristic concept. And you all know that it's already quietly and powerfully reshaping our everyday life. From the moment you unlock your phone, to the songs you listen, to the movies you watch, to the paths you take, AI is working behind the scenes. But what is this thing we really call AI, or artificial intelligence? And how did we get here? Today, we're going to strip away the technical jargon and discover what AI truly is, how it works at its core, and trace its incredible journey from a curious idea to the transformation or the transformative technology it is today. Let's break it down simply. At its heart, artificial intelligence, or AI, is about making machines smart. That seems easy, right? But not smart like the calculator that just crunches number you give it, or just crunches numbers you give it, but smart in a way that it mimics human intelligence. Think about what makes us intelligent. We learn from experience, we solve problems, we understand language, we recognize patterns, and we make decisions. AI is simply the science of teaching computers to do these kinds of smart things. It's about giving a machine the ability to perceive its environment, like a camera seeing, or giving it a reason, like a computer thinking, or making it learn, like you learn from mistakes, and then it would act based on that learning to achieve a goal. So you can look at it like, it's like being a student, but instead of the student being a human being, it's made of code and hardware. This student can get really good at specific tasks, even sometimes better than humans, because it processes information at incredible speeds and scales. The idea of machines thinking isn't new. It's fascinated us for centuries, but the real spark for modern AI came in the mid-20th century, thanks to the brilliant minds of Alan Turing. Now, Alan Turing, a visionary British mathematician, often called the father of theoretical computer science and artificial intelligence, posed a profound question in the 1950s. Can machines think? This wasn't just a philosophical debate. He proposed a way to test it. He introduced what now is famously known as the Turing Test, or the imitation game, which we'll talk about later in the series. But imagine you're chatting with someone through a computer screen, but you don't know if it's a person or a machine. If after the conversation, you can't tell the difference, if the machine can trick you into believing it's human, which is already happening today with LLMs, then Turing suggested perhaps it can be considered intelligent. This was a revolutionary way to think about defining machine intelligence, shifting the focus from how does it work to what can it do. Now, Turing's work laid the philosophical and conceptual groundwork, right, showing that it was possible for machines to perform complex computations and potentially exhibit intelligence. He envisioned a future where computers could learn and adapt. Now, in the 1950s and 60s, fueled by Turing's ideas and the invention of the first electronic computers, the field of AI really took off. Researchers were incredibly optimistic, thinking they were just a few years away from creating truly intelligent machines. They focused on things like problem solving and symbolic reasoning, trying to program computers with all rules of human knowledge. So the early days and the hype was when Turing's ideas and invention was still going on so much that they were focused on thinking about problem solving and symbolic reasoning. And then there was another season called the AI winters. And the AI winters came because progress was slower and harder than they had anticipated. Computers weren't powerful enough and data was just scarce. And this led to, this AI winters. This was during the 70s and 80s, where funding also dried up and enthusiasm waned away because AI couldn't deliver on its grand promises. Then, fast forward to the 2000s and beyond, and something incredible happened. We gained access to massive amounts of data and incredibly powerful computers. And this combination, especially with the rise of machine learning, which is a subset of AI, where computers learn from data without being explicitly programmed, it breathed the new life into the field. Suddenly, those dreams of intelligent machines started becoming a reality, not by teaching them every single rule, but by letting them learn from examples, just like we humans do. I know you may be asking, how does this learning actually happen for AI? It's often through something called machine learning, which you've already heard of, and which is the dominant way AI works today. So imagine you want to teach a child to recognize a cat. This is a typical example used. You don't give them a list of rules like it has 4 legs, it has fur, it has points, it meows. No. Instead, you show them many pictures of cats and many pictures of non-cats. After seeing enough examples, the kid or the child starts recognizing the patterns that define cat. This is actually what happens, right? This is how we learn. Now, AI learns in a very similar way. We feed it enormous data or enormous amounts of data, pictures, text, numbers, and sounds, and sophisticated algorithms find patterns within that data. If we want an AI to identify maybe a spam email in your email box, we feed it millions of emails labeled as spam and some labeled as they're not spam. The AI learns what characteristics typically show up in the spam. You don't tell it in a spam you're going to find maybe fraud or you'll find some misalignments in the email. No, the computer itself learns the characteristics. If we want an AI to recommend movies, we give it data on what movies millions of people watched and liked. The AI spots patterns in preferences. Once it has learned these patterns from the training data, it can then apply that knowledge to new unseen data to make predictions and decisions. This is the magic. Well, it's not magic, of course, but it's complex mathematics and statistics at play. This is why data is so crucial. The more high quality data an AI system has to learn from, the smarter and more accurate it can become. So we usually say whatever it is you input into an AI system for training, or whatever data you feed in, you get the same output. Whatever input you give, you receive the same output. You feed in jargon, you receive jargon. You feed in quality, you receive quality. So when we talk about AI, it's important to understand there's a spectrum of smartness. And what we have today is very different from what you see in science fictions or movies, right? So there's narrow AI or artificial narrow AI, generally considered ANI. And this is what nearly all AI around us is today. It's AI that's really, really good at one specific task. Your phone's face recognition, that's artificial narrow AI. I mean, the AI that plays chess better than any human, right? That's narrow AI. It's the recommendation machine used on Netflix. And these systems are incredibly powerful within their specific domain. They are highly specialized tools. Then we have artificial general intelligence or AGI. And this is just the holy grail of AI research. It refers to AI that can understand, it can learn and apply intelligence at any intellectual task that a human being can. It could learn new skills, solve unfamiliar problems, and reason across different domains. This is what you see in movies like Star Trek. We are not there yet, okay? Now, the next type of AI is superintelligence or artificial superintelligence, AI, super AI. And this is a hypothetical AI that will surpass human intelligence across virtually all cognitive tasks, including creativity, problem solving, and social skills. This is still firmly in the realm of science fiction, but it's a concept that drives a lot of both excitement and ethical discussions about the very distant future of AI. So for now, we're just going to focus on narrow AI. That's the powerful and practical technology transforming our world today. So why is understanding this fundamental concept of AI so powerful for you, especially in your career and daily life? AI is no longer just in the trenches, right? It's rapidly becoming the foundational technology across every single industry, whether in healthcare, finance, marketing, education, or even in the creative fields. AI tools are changing how work gets done. It's about empowerment and not replacement. Learning about AI isn't about becoming a programmer. It's about becoming AI literate. It's about understanding its capabilities, its limitations, and how to harness its power as a tool to solve problems, innovate, and make better decisions. It's about asking the right questions. Knowing the basics of AI allows you to critically evaluate claims, understand potential risks, and identify opportunities for growth, both personally and professionally. It's about being prepared for the future. Just as digital literacy became essential, AI literacy is quickly becoming the next must-have skill. I take that back. Is the next must-have skill. So this course isn't just about learning about AI. It's about learning how to thrive in an AI-powered world. So we've covered a lot today, right? We've demystified AI as machines that learn and make smart decisions. We've traced its origin back to the pioneering questions of Alan Turing, and then understood how it learns through patterns, and differentiated between specialized AI of today and the more general AI of tomorrow, which is still a myth. And so this foundational understanding is your first step to becoming truly AI literate. We're building this knowledge brick by brick, right? Now that we have a solid understanding of what AI is, we can continue to build our comprehensive knowledge base. Next, we're going to revisit the different types of AI in details, and then as we begin discussing, we're going to explore how AI moves beyond the scene into the physical world. So don't forget to like this video, subscribe for more insights, and hit that notification bell so you don't miss any part of this journey. We're going to create the next series of this course. It's a fully fledged course which would lead from AI literacy down into AI governance, responsible AI, and AI ethics. And I'll be sharing the resources you can use for this. And this is a full course. If you're interested in the whole course, just, enter your email below in the waitlist. And once the course is released, I'll be sure to let you know and you take the full course. Okay, I'll see you next time. Bye.